Hi, let's see the question together. The question is asking us to prove square root 6 is an irrational number. And the first step is assume square root 6 is a rational number. This used the proof method called contradiction, which means if we want to prove a statement A, we can prove not A is false. So where we want to prove square root 6 is an irrational number, so we prove square root 6 is rational number, which is wrong. So we assume square root is rational number first. And second step, we know the definition of a rational number. We can write in the form a divided by b, where a and b both are integers. Therefore, we can write square root equals to a over b. Due to we assume square root 6 is a rational number. The next step, assume that a over b is the simplest form, which means every d belongs to the integer set. If d is divisible by a and d is also divisible by b, then d can only be 1. This is because we said a over b is the simplest form, which means a and b has no common factors except 1. Therefore, d can only be 1. We can keep this in mind and go to next step. The next step, square root both sides. A squared equals to 6b squared, and a squared is divisible by 2 and 3. First, we can start from this equation. Square 6 equals to a over b. And if we move b to the left-hand side, we got b times square root 6 equals to a. And squaring both sides. So squaring both sides, b squared times 6 equals to a squared, which is same as this equation. And because a and b has no common factors, and b squared equals to b times b, a squared equals to a times a, and b and a has no common factors, which means b squared and a squared also has no common factors. Therefore, in this form, b squared times 6 equals to a squared, so a have to be divisible by 6. And due to 6 equals to 2 times 3, therefore if a is divisible by 6, then a have to be divisible by 2 and 3. Then the next step, a prime dividing a squared must also divide a. We said because a squared equals to a times a, so a squared must also divide a. Therefore, both 2 and 3 divide a, because a squared divides 6 means a times a divides 6. If we write it in a times a over 6, we can see a divided by 6 have to be an integer. Therefore, a is divisible by 6, so both 2 and 3 divide a. And this means we can write a in a equals to 6k, where k is an integer. So there exists an integer k, can write a equals to 6k. And if we substituting this into this equation we got, and we have 6k squared equals to 6b squared, and we expand this, then 36k squared equals to 6b squared, and we divide by 6 on both sides, then it's 6k squared equals to b squared. Now we got b squared equals to 6k squared, which means b squared have to be the multiple of 6. And we already proved here, if a squared is divisible by 6, then a have to be divisible by 6. So same here. If b squared is divisible by 6, then b have to be divisible by 6. So we found now b squared and hence b is also divisible by 6, and as well as a is also divisible by 6. Because we already assumed that a over b is the simplest form, so they have the only common factor is d, which is 1. Therefore, this is contradict the assumption that a and b have no common factors. And due to the logical we learned, if this statement is false, then the negation of this statement, which is this, it should be true. So we got the conclusion. Therefore, square root 6 is an irrational number, which is true. That's all. Thank you.